So let's have a look at some of the platform services or managed services. I'm not going to spend too much time on this particular slide. Well, certainly not as much as the foundational slides that we just looked at, because all these are high-level abstractions on the core stuff. For example, we have Amazon RDS, right? That's a relational database service. Now, of course, you could launch an EC2 instance and put MySQL on there and manage that yourself. But there's a lot of headache involved in that. You'd have to deal with the backups, you have to organize failover and all these other things you'd be associated with database admin. Well, with RDS, it's just a managed version of doing that, so that AWS will alleviate some of that headache for you. And all of these services do essentially the same thing. They're managed services. And again, look Elastic Transcoder. Right? That's an ability to transcode video from one format to another, or an image format to another. Of course, you can go to EC2, install FmpEg, and do all those fun things yourself. But no one really wants to do that, because we have managed services for that. It makes your life a lot easier. So that's the theme and the general idea behind these platform services. So again, I'm not going to go into detail, but I'm just going to give you a quick, maybe a minute or so explanation on each one, just so you're aware of what they are. Now, of course, there are more, but these are the main ones. And then I'd rather spend more time getting involved in things like VPC and IAM and more of the important stuff. Alright, so let's start just covering some of these things. Let's look at RDS real quick. This just stands for Relational Database Service, whether you're using MySQL, Postgres, MySQL Server, Oracle. Now, these are very common databases that people use, and so you can use that in the cloud. We also have our own Amazon Aurora, which is essentially a drop-in replacement for MySQL. Again, check the docs to see the differences. And we also have a migration service. It's not on the slide, but if you have your on-prem system and you need to get your database into the cloud, we have lots and lots of different options to help you get your database, or whatever version of database you got, into the cloud, and we even switch it to a different style of database in the cloud. So this is a managed service, meaning that we will alleviate the headache of database admin for you. That's the core selling point. Amazon RDE, again, all of these managed services. DynamoDB is a system that lets you scale out horizontally, meaning that once you start throwing data into DynamoDB, it will automatically scale out horizontally across more and more machines. That is in contrast to RDS, where you just have one massive box. And if you need a bigger box, you go and buy a bigger box. That's called vertically scaling. DynamoDB will scale out horizontally. Also, it's a NoSQL store, so it's slightly different flavor than your traditional databases, your relational databases. I'm not going to go into the details about the difference between NoSQL and SQL here. Reason being, I'm going to spend a bit of time on a module later on discussing RDS and then striking a contrast to Dynamo. So at this stage, just know this is a different type of database system than this one. That's all you need to know at this stage, because we're going to go deeper later on. Let's have a look at Elasticache. So Elasticache is an in-memory data store. That means instead of using solid-state drives, which you have on DynamoDB, you're actually storing everything in memory. There's no point doing a very complex query on MySQL over and over and over and over if you're going to get the same response every time. You might as well just store the response in memory and use that as a caching mechanism in front of your database to alleviate the load on your databases and store everything in memory. It's just a common caching concept called Elasticache. Oh, and just FYI on that, we have two flavors of Elasticache, Redis and Memcached. And again, if you're looking at the differences between those, I'm just going to refer you to the docs at this point. I don't want to go too deep on that, but they're essentially key value pair stores to allow you to do caching on these layers. People often use those things for session servers as well. It's also a very common use for Elasticache, Redis. And finally, Redshift. This is a columnar data store. It's designed to handle really complex queries for analytics. It's done in such a way that you can run queries in parallel, and it's designed for massive amounts of data. This is the whole concept of big data, which I'm going to go into in a second, but this is a data warehousing solution. For those of you who are involved in data warehousing, this is our flavor in the cloud. And again, reason why I'm not going deep on that one is because we do a whole 3-day course on it to give you an idea of how complex Redshift can be. So these are big data concepts: Kinesis, EMR, which is managed Hadoop in the cloud, and data pipeline. If you're already familiar with MapReduce and Hadoop and Spark and these kind of technologies, well, we have a whole system called EMR, which actually can get very involved. We do 3-day courses on this too. So this can be quite involved. If you're involved in that big data world, then we have that in the cloud. This is for cold data, but for new data, meaning like hot data, things that have just happened as in right now, we can have real-time analytics with Amazon Kinesis. This is a stream that can ingest many different types of data from various different sources in massive amounts, and you can analyze those pieces of data from various consumers in various different ways and make sense of real-time data. And then of course after it's gone through this real-time hot stage and starts to cool down, becomes older and more stale, that can be stored in S3 and analyzed with Managed Hadoop here. So these are just big data concepts really. And as far as data pipeline, if you have data in one format, you need to translate it into another and move data around in terms of a workflow. Well, obviously that can get a little complex, so we have a managed service called Data Pipeline to, again, try and make your life a little bit easier when you're moving tons of data around all over the place. So that's big data and analytics. As far as app services go, I already mentioned Elastic Transcoder and what that does, so I'm not going to cover that again. As far as cloud search is great if you're doing full text search, trying to make sense of phonetics, that kind of stuff. Very often a lot of traditional databases don't do that so well. For example, if you're using MongoDB on an EC2 instance and trying to do full text search on those items, it works okay, but sometimes there are better technologies for that. And cloud search is a high level abstraction on those to make it very easy for you to do full text searching and doing phonetics such as the search term, does that sound like this? Did you mean that? That kind of stuff for your application. Managed service, very cool. SES, simple email service, bit of a giveaway because the email symbol up here. When you have people sign up for your application for a website, for example, you probably send an email saying, thanks for joining, or you send an email if there's a new service coming out. These are campaign emails or transactional emails. And we have an option within SES to coordinate that stuff. And I will say, on the plus side of AWS, that it's really inexpensive to use SES compared to a lot of the third-party vendors that are out there. And SES allows you to do some really low-level stuff with your email, controlling all the keys, controlling security, making sure that everything's all validated. I'm not going to go into the details, but very, very fine-grained control over your email sending and provisioning, and it's really, really inexpensive. And it's a great service. You should definitely look at it. It's one of my favorites, that. And finally, SWF Simple Workflow. When you're moving data around or you're going through certain processes, you can very often have computer processes going from one step to another, and everything is nice and organized. What happens when human beings are involved? It becomes a little less organized. I'll give you an example. Say you have a credit card transaction on a website. You need to validate that. Now, if that credit card validates, you need to do one thing, and if it doesn't, you need to do something else. But what happens if it does validate? Then you have to then go and place an order, right? Then that order has to be, maybe you have to page someone in a warehouse to go and put something on a shelf. And as soon as you have that human being step involved, processes are going to time out. If you did them through normal computerized processes, you might need a month or a week or a year before these processes occur, and you need to keep track of the state of all these processes throughout that whole life cycle. So obviously, trying to manage that yourself can be a little complex. So we have a system called SWF which takes care of a lot of that stuff, and again, I could spend a lot of time on this, but I'd rather not. I think there are other technologies I'd rather spend time on, but SWF is extremely powerful if you've got lots and lots of processes and you're trying to organize a workflow. So as far as development and management goes, code commit, that's just a repository for your code. If you guys are familiar with things like GitHub or Bitbucket, well, this is the AWS one. Does it have all the functionality of GitHub? Not currently at this point in time, but I think over time it will have. So before switching over to code commit from, say, GitHub or Bitbucket, I just have a look at the docs, make sure it does exactly what you want. They're improving things all the time, integrating all other services, but it's just our version of GitHub equivalent. Try to be. Right, what about code deploy? Well, when you push something to code commit, you may use another service which isn't even listed here called code pipeline, and that's going to put everything through a certain pipeline process, and then once that reaches code deploy, it will take your code, which you may have on code commit or GitHub, actually it's compatible with that, and it will drop it in to your machines and do a rolling update on your instances. So if you have like 10 instances in the cloud, your latest code can go to the first 2, and then if that works, then the next 2, and then the next 2, and then the next 2. If there's a problem, you can roll it back. So this is nothing more than the concept of DevOps and organizing a workflow of your code base. These ones up here, let's start with Beanstalk. So Beanstalk high level, it means if you want to have an EC2 instance and put WordPress on there, you could do that, of course, but Beanstalk has a lot of pre-configured systems that you can take advantage of. You can say, I would like to have a Node.js website using a particular version of Node. I'd like to add a certain type of database to that. I would like to have load balancing and auto scaling. And you define the key concepts that you want, but you don't have to go and organize the granular detail that you would normally do if you were building your own VPC and organizing EC2 instances. So there's an abstraction for you as a developer. You can just literally give them your code with eb deploy from the command line. It's like a git push of sorts. You push your code into Elastic Beanstalk, and it will take that code and then provision all the infrastructure around it, and trying to hide away from you guys a lot of the headache and a lot of the complexity involved in organizing that stuff. Now, of course, because it's so opinionated, sometimes you might have to tweak it with a bit of configuration, make it do exactly what you want. I'll give you a quick example. I was experimenting with a Node.js app at one point, and it was working great. I was putting it through Beanstalk. Then I went back and I started implementing a new version of Node.js on my local machine. Turned around to push that to Beanstalk, and Beanstalk's like, well, no, we're too opinionated. We don't have that version of Node, right? So at that point, it's like, how frustrating. Luckily, what they have though is Docker containers, which means that I was able to configure my Node.js app into a Docker container and just give it that. So even though it's very opinionated and sometimes you think it won't fit your exact criteria, if you use Docker with this, you can customize it pretty much to the nth degree. One thing I would say though is if you're going to really customize things and take advantage of things like reserved instances, spot instance pricing, and do some really advanced stuff, even more outside of the configuration you have in a Docker instance, you're probably going to have to move over to this guy over here. CloudFormation. CloudFormation is really powerful. CloudFormation is a scripted environment that shows you exactly what your infrastructure is doing. So instead of going into the console, which the AWS console, and pressing buttons, launching EC2 instances and this kind of thing, you can just write a text file as JSON. As JSON is just like a text format, and you would literally write down your infrastructure. So I'd like a VPC, I would like this amount of EC2 instances, I want this auto scaling group, I want this load balancer, and you can get really detailed with a text file. Now, it sounds easy, doesn't it? Oh, your infrastructure is a text file. Well, conceptually it's easy. The challenge is the CloudFormation has quite a few nuances to it, and it's not the easiest thing in the world to work with. However, if you're willing to take the time to learn CloudFormation, it's one of the singular most powerful things you can do at AWS. If you can understand CloudFormation, you can build your entire infrastructure, everything you've seen or everything I've shown you so far, from a text file. Which means when you make changes, and something didn't work, you can roll back to the previous version because you can check in your infrastructure as code into a version control system like code commit. Anyway, enough about that. We do advanced courses on this, but it's very cool. Definitely pay attention to CloudFormation if you ever get a chance to look in the docs. And finally, as far as managed services go, we have Cognito, SNS, and Analytics. Analytics is easy. If you're building, say, an iPhone app or an Android app, and you want to collect a lot of information and then send that up to the cloud for analytics to find out who's doing what on your application, we have SDKs for that. I'm not going to go into detail about that. It's pretty edge case, but it's pretty cool as well. SNS, Simple Notification Service. This means that if you maybe push something into S3, throw an item into S3, you can then have a notification process set up so that you can have another part of your infrastructure react to that. Okay, essentially triggers. This is a broadcast system, meaning I can have an EC2 instance and I can say something has just occurred. I'm going to send that onto a simple notification service. And you can have all these different subscribers. This could be an email. This could be a simple queuing service, which we haven't really got into because it's kind of out of the bounds of this course, like a messaging system. Or you could have a Lambda function, all subscribing to this notification topic. So when something occurs, it pushes it to the topic, and then this topic will then send information to all of these resources, and they can react accordingly. This is a very cool broadcasting system. That's all that is. And last but not least, Cognito. Cognito is nothing more than authentication. You might want to log in with Facebook, Google, or Amazon, not want to build your own authentication system. And as such, you can use their authentication system to log in. Say, for example, you log in with Facebook. Right? Facebook is going to give you, behind the scenes, a little token saying, okay, great, you're logged in. You can use that token, send it over to Cognito, and then you're logged into AWS. So it's using a third-party system for authentication. Is there more to it than that, such as storing data across devices? You could have an iPad, you'd be playing a game on your iPad, it'll remember where you're at, and then you go onto your mobile phone and you can carry on from the same level. It has that kind of functionality. It's not just authentication, but generally that's what it's used for. Okay, that's pretty much it for all the managed services. Hope that's given you some idea of what we cover. There are more services, I've mentioned that a few times, but I think I'd rather get onto some of the other stuff now.